This is a NEET 2019 question basing on vertical circular motion. Problem is like this. A mass M is attached to a thin wire and is held in a vertical circle. The wire is most likely to break at what point, right? Let us consider what he's saying. There is a mass M attached so that it is moving in a vertical circle. The body could be anywhere, right? It could be here or here or here or here, any of these places. Actually, these are the four options given to our problem itself. Where it could break, right? Likely to break. First of all, when it will break is the wire most likely to break when tension in it is maximum. So at each of these points, let us try to find out what is the tension is so that we will be able to identify, right? Let us first consider when the wire is at horizontal. This is the case. Here, what are the forces acting? Its weight mg is acting downwards. Tension always acts towards the point of suspension. Being the body is in vertical circle, what we can say is at horizontal position, the only force that's acting towards the center is tension. That tension provides the necessary centripetal force so that the body can move in a circular motion. So if the body is moving at this instant with a velocity v, tension at the horizontal position is mv square by r. Now, when the mass is at the lowest point, let us consider this point now. When it is here, what are the forces acting? Weight mg obviously downward direction, tension T towards the point of suspension. So what we can say, at bottom, centripetal force is provided by the effective of these two forces. As the centripetal force is towards the tension, forces towards the tension shall be treated as positive. Forces against the tension shall be treated as negative. So T at the bottom is mv square by r plus mg. That is option 2. Let's have a look at option 3. When it is at an angle 60 degree to the inclination, right? So I will draw a diagram again so that it will become comfortable to draw what I would like to say. When it is at an angle 60 degree to the vertical, this is vertical, this is 60 degree. So here particle is there, its weight mg acts like this, which can be resolved into components. As this is theta, this also becomes theta. This is adjacent component mg cos theta. This is opposite component mg sin theta. Tension obviously acts towards the center, right? So what we can say, at an angle, centripetal force mv square by r is, as we are writing a force towards the center, force acting towards the center shall be treated as positive. Mg cos theta is acting away from the center, that is minus mg cos theta. So T equal to mv square by r minus mg cos theta. That is mv square by r minus mg cos 60. That is mv square by r minus mg, right? So, yeah, tension is equal to, I have missed one point, right? Tension equal to mv square by r. This minus mg cos theta, when it goes to the other side, it becomes a plus, right? So this is plus. Be careful. This is plus, this is plus. Cos 60 is 2. So this is mv square by r plus mg by 2 in a horizontal position. Have you noticed it? From here, to get the tension, I have to take this to the other side. Minus on this side, when it goes to the other side, becomes a plus. Now the last one is when it is at the highest point. So let us write down at highest point here. Of course, weight mg will be downward, tension also towards the center. So centripetal forces, both of them are acting towards the center, so both of them has to be added up. So tension at the highest point is mv square by r minus mg. So you can look at four options. When it is horizontal, it is mv square by r. At the bottom, mv square by r plus mg. At an angle 60, mv square by r plus mg by 2. At the top, at the highest point, so this is highest. At the highest point, mv square by r minus mg. So who is highest in all these cases? It's very clear. This is highest. So tension at the bottom and the mass is at the lowest point. It is more likely to break based on this concept. So while solving this problem, we have explained a lot of concepts also. Please go so that you can understand how do you write an equation for centripetal force in any circular motion. That's it. Thank you for watching.